to explain a little bit about what a complex number is. And a complex number, 5 plus 3i, it's a point on a graph. And we have the real part, which we learned yesterday. There's the real part, and the other part is the imaginary part. So we have the real part and the imaginary part. And we can graph it on a coordinate system. And it's simply 5, 3. 5, 3. So that would be 5 plus 3i. All right, I'll try and explain a little bit. We use imaginary numbers in, if you're an electrical engineer, if you're an electrician, it has to do with a current flowing through a wire. That's about all I can tell you. Yeah?
Does that mean that the point is going to be in either the first or second quadrant?
No, it could be in any one of the 4 quadrants. Okay, I'll give you an example in just a second. Okay, we have our real number here, which is the x-axis, but instead of the y-axis, we're going to call this the I-axis. So that if I graph 5 plus 3i, it's 5 over and 3 up. And if I did negative 2 minus 7i, that's also in the form a plus bi. And the point would be negative 2, negative 7. So it would be down here. That's where that point would be. So it could be in any quadrant. On your test, I'm going to say plot the point. And it's simply that. And I think, normally, we haven't gotten into it too much, but it's at distance from 0 to that point, all right, which is kind of the current flow of the and again, I'm not sure how to explain it because I really don't know that much about it. I can do the math on it, but I don't know too much about the history of it. I've Googled it, I've read about it, and it's a little bit confusing. So, all right, so that's what a complex number is. All right. We also had this information that I is a representation for the square root of a negative number, typically a square root of negative 1. And that's what I is. We never, when you see I in an equation, when you see it in some type of a problem, we never change I back to the square root of a negative 1. We never go that way. Once we get to I, that's it. And we learned yesterday that I squared is equal to what? What is I squared? Negative 1. So that whenever I see I squared, stands for negative 1. I think one of your problems yesterday was negative 3i squared. And the properties of I are just like the properties for a variable. So if you're asked to do a problem like negative 3i squared, it is a positive 9i squared. Of course, we know I squared is negative 1. So 9 times negative 1, the answer to this is negative 9. Right. Well, I cubed, isn't I cubed I squared times I? Doesn't that equal I cubed, adding the exponents? Well, I squared is negative 1 times I cubed is negative I. What is I to the 4th? What do you think I to the 4th might equal? What is it?
1.
1. Because you can think of it this way. I squared times I squared. Negative 1 times negative 1 is a positive 1. These are the only values that we're going to get, no matter how high the exponent gets. For instance, what do you think I to the 16th would equal? 1. because it's I to the fourth times I to the fourth times I to the fourth times I to the fourth, or 1 times 1 times 1 times 1. As long as the exponent is divisible by 4, it equals 1. Yes, Michelle?
I don't understand how I cubed is negative I.
Well, because I cubed, isn't that I squared times I? Okay, and I squared is negative 1. Negative 1 times I is negative I.
So it'd just be like negative square root of negative 1.
No, we never go back to the square root of negative 1. It's just negative I. That's it. Okay? Yes?
I'm a little confused about the I cubed too, because if you had negative I, because I just equal, no, I squared equals negative 1.
Correct. And negative 1 times I is negative I. Okay? Let's,
Oh, so you have I squared which is negative 1, and you multiply it by another square root of negative I?
no, you might, no. I'll try and explain that to you a little bit later. Once you get to I, you never go back to the square root. It's I is simply I, that's it. I gives us it tells us how to take the square root of a negative number. I don't want to spend too long on explanation of this. Understand the math on it though. Okay. If I had I to the 32nd, what would that equal? What is I to the 32nd? 1. Okay, because 32 is divisible by 4. But what if I had I to the 35th? Well, I can write I to the 35th as I to the 32nd times I to the 3rd, correct? And what's I to the 32nd? 1. And what is I cubed? Negative I. 1 times negative I is negative I. So I to the 35th power is equal to negative I. I to any power is going to give you one of these answers. It's either going to be I, negative 1, negative I, or 1. Okay. All right. Well, let's move on. Let me pause this for just a second. All right, so I want to take problem number 27. We have 5x squared minus 5x plus 2. Right. And first of all, let's see how many solutions this has by looking at the discriminant, which is b squared minus 4ac. The first number is always a positive number, always 25. Don't use your calculator just yet. Minus 4 times a times c. And I don't think we need a calculator for this. 4 times 5 is 20. 20 times 2 is 40. So 25 minus 40 will give us a negative 15. That's my discriminant. It tells us we have no real solutions. What that means is this parabola is up in one of the quadrants. Because we know it opens upwards because of the positive 5. Once you find the discriminant, it makes the solving of it a little bit easier. Because now I can write the quadratic formula, the opposite of b, plus or minus the square root of the discriminant, b squared minus 4ac, which we found to be negative 15, all over 2a. And 2 times 5 is 10. Now that I have a negative inside the radical, it's negative 5 plus or minus I square root of 15 over 10. And now I'm going to take my answer, which is what you should have got for problem number 27. We cannot reduce the negative 5 and the 10. You cannot reduce those two. Not unless you can reduce all three terms. This one, and this one. Okay? But you're going to notice in the book, it does break it apart. And let me show you how to break it apart, to put it in the form a plus bi. What this equals is negative 5 over 10 plus or minus I square root of 15 over 10. And now I can reduce to negative 5/10 to make that negative 1/2 plus or minus, and then I'm going to write the square root of 15 over 10, and I'll take the I and I'll just put it over at the end there. So then this is in the form a plus bi, where your a is negative 1/2, the b is the square root of 15 over 10. Okay? So we've kind of taken that one step further. All right, any questions? Yes?
For the test, would you want us to write it in the complexes?
Yes, because there's going to be some multiple choice questions on your test, and there's going to be some fill-ins, but the directions will say, write your answer in the form a plus bi. And especially if you're taking the ACTs or you're taking a multiple choice question, you might get an answer that looks like this, and this is one of your choices down here. That might be one of your choices. So you're going to have to know how to get from here to here. All right? Okay, yes?
Isn't it the opposite of b plus or minus square root of b squared minus 4ac?
Oh, it is. So that becomes a positive 5, and it becomes a positive 1/2. Good one, Kelsey. Okay, it is the opposite of B. All right. Okay, yesterday we talked about in class how to add these complex numbers. Add or subtract, and it's all the same thing. Here's two complex numbers. And the way we add or subtract basically is combining like terms. We have 3 minus 5 will give us a negative 2. And 2i minus a negative 7i. Don't forget to distribute that negative here and here. So 2i minus a negative 7i gives us a positive 9i. I don't think we'd have too much trouble doing that, would we?
No.
No. All right. So let's do some multiplication. Let's take 3 plus 2i times 2 minus 5i. That's surprising how much that goes off, isn't it? Is that one time is that every 22 minutes? Somebody in the United States, is it? Or in Michigan? United States. Yeah, somebody, that would make sense. Somebody in the United States. All right. Distracted driving. All right. You guys haven't been around when we've lost one of our students, and it's a sad situation. Very sad. All right. Well, let's use FOIL. 3 times 2 will give us 6. And then the outside terms. 3 times negative 5i, negative 15i. Okay. Also, we're going to write our answer in the form a plus bi. I have 2i times 2, that's 4i, and 2i times a negative 5i would give me a negative 10i squared. Okay, so let's combine terms. Negative 15i plus 4i will give me negative 11i. And what can you tell me about this negative 10i squared? What does that equal? Positive 10, correct? Because I squared is negative 1. Negative 10 times negative 1 is positive 10. And I can combine the 6 and the 10 to get 16 minus 11i. You me to do another problem like that? Showing you FOIL?
Yeah.
Yes? Okay. And let's make up one. Jesse, why don't you give me one that we can do? Any numbers at all?
7 plus 12
Times.
2 minus 13.
Thank you. Okay, so we'll use FOIL. So 7 times 2, that'll give us 14. 7 times negative 13 will give us a negative 91i. And then I have 12i times 2 will give me 24i. And 12i times negative 13i will give me a negative 156i squared, if my math is correct. We have 14. Combining these two middle terms, and we have 77. Is that minus 77i? Negative 91i plus 24i. And what about the negative 156i squared? What does that become? Positive 156.
77 is supposed to be negative 66.
Which one?
71 is 24 is 67.
Oh, it's 67? Okay. And 14 plus 156 is 170 minus 67i.
Okay.
Yes.
Why did we go from negative to positive?
What is I squared? Negative 1. So I have negative 156 times negative 1 makes that a positive 156. Okay? Now, let's see what happens when I take a complex number. Well, before I do that, I wonder if you guys ever heard the word conjugate. You should have had the conjugate in geometry. If not geometry, algebra 1. But it should have come up a lot in geometry. Conjugate. So if I asked you, what is the conjugate of x plus 3? Would anybody know what it is? Nobody?
Is it negative 3?
No. The conjugate of x plus 3 would be x minus 3. It's whatever you multiply by to complete this, or to have the difference of two squares. And if I multiply x plus 3 by x minus 3, what happens to the outside and inside terms?
Cancel out.
They cancel out. And what I have is x squared minus 9. And that's the conjugate. The conjugate of x plus 3 is x minus 3. The conjugate of x minus 3 is x plus 3. All right? And also, just as a reminder, if I had number 3 over the square root of 5, okay? And again, in geometry, we rationalize the denominator. It means we can't have a square root in the denominator. So I need to multiply by something to get rid of that square root. So I'm going to multiply by 1, so I don't change the value. But I'm going to multiply by the square root of 5 over the square root of 5. On top, for my numerator, 3 times the square root of 5. On the bottom, the square root of 5 times the square root of 5 is what? It's 5. It's the square root of 25, which is 5. So that this value and the original are the same value. But I've rationalized the denominator in order to get the square root out of the denominator. It's called rationalizing denominator. Okay, follow me? So, let's get back to this conjugate. Three plus 2i. What is the conjugate of 3 plus 2i? Yeah, 3 minus 2i. All right? Let's see what happens when I multiply a complex number by its conjugate. Using FOIL, 3 times 3 is 9. The outside terms, negative 6i and a positive 6i, will cancel each other out. And then 2i times negative 2i is a negative 4i squared, which becomes a positive 4. And 9 plus 4 is 13. So if I multiply a complex number by its conjugate, the result will be a real number. Okay, we've eliminated the i's. So how will that help us? Well, if we take an example like, and I'm going to go to the next screen here. 2 plus 5i over, let's say 3 minus 6i. All right. If you know what the I is, we know that that's a radical. That's a square root. And we need to get that out of the denominator. And I know that if I multiply 3 minus 6i by its conjugate, I'll get a real number. Let's put parentheses around the numerator and denominator. And I'm going to multiply top and bottom by the same thing. And I'm going to multiply by the conjugate of 3 minus 6i, which is 3 plus 6i. Three plus 6i over 3 plus 6i is 1. So if you take any number and multiply it by 1, you get the same number. All right? So let's do that. And let's look at the numerator and use FOIL. 2 times 3 is 6. 2 times 6i will give me 12i. 5i times 3 will give me 15i. And 5i times 6i and give me 30i squared. In the denominator, 3 times 3 will give me 9. I know that the outside and inside terms cancel out. 18i minus 18i. And negative 6i times a positive 6i will give me a negative 36i squared. Okay? So let's look at that numerator. That plus 30i squared will give you negative 30, because I squared is negative 1. So if I have the 6 and the negative 30, that's negative 24. 12i plus 15i, 27i, over, and what do I have in the denominator? What is negative 36i squared? Plus 36, 9 plus 36, 45. All right. Do all three numbers are divisible by what? 3. Okay. So negative 24 divided by 3 is negative 8. 27 divided by 3 is 9. And 45 divided by 3 is 15. Okay. I'm going to put this in the form A plus BI. So we can split this up. Negative 8/15 plus 9/15 I. And tell me about the 9/15. 3/5. So be careful on your reducing. Okay? Are we okay with those? All right. The homework for today is going to be on page 320, 42 through 79, all. And you can add that on to what the homework that I gave you yesterday, and I'll collect both assignments tomorrow.